we have a team of two, Daryl Chapman and me, Weizong. We are both software management students of class 2014. Here is our major findings. We have found in total 10 vulnerabilities. Of the 10, 5 are with high risk, 3 are with medium risk, and 2 are low risk. Alongside with the findings, we have also proposed solutions as to how to fix the vulnerability and mitigate the risk. So how did we find the problems? What is our methodology? So basically, we have navigated throughout the website, trying different things like creating a username, login, logout, adding items, removing items, and checking out. We also use the developer tools provided by browsers extensively to check the source code, network traffic, HTTP requests, the cookie settings, and the certificates. We also tried to emulate text by, for example, search some strings that contains JavaScript. So let's see what we've got. First of all, we found the Ninja Shop is pretty weak in terms of input validation. It has a search box, and when the search results is returned, the original search item is reflected. We are actually able to display a cookie in the search box if we search this string with three leading double quotes. What's interesting is that the input validation is not total missing of total failure. It actually works for 1 double quote or 2 double quotes, but not 3. So it does have some sort of input validation, but it's not robust enough. Apparently, if we can display cookies, the hackers will steal the cookie by using XSS. We've tried 2 browsers. The attack actually works for Firefox, but the attack was actually detected by Chrome. Chrome refuses to execute the script, but we can actually see from the debug console that something is being detected by Chrome. Let's switch to Daryl.
Thanks, Wei. So let's extend the discussion about cookies that we just Wei started here. So very easily, by just using the site and looking at our own browser, we can see what kinds of cookies are being downloaded. They do have one good practice, which is you come to the site, it offers certain cookies, and you exchange cookies, and then upon login, it regenerates a new cookie for the session. Having said that, the cookies that are offered are unsecured cookies. So unlike Google Drive, which is using HTTP-only cookies, they're not doing that here. So Wei's script is able to succeed, his JavaScript is able to succeed against the cookies that are there. So that's a vulnerability that allows attacker to possibly have a better shot at change. So by simply using HTTP-only secure cookies, then they could improve the security of the site. Error display. So on many sites, if you don't suppress error messaging, you can tell the whole world a great deal about your site. Is the hacker can cause the site to error and get messages displayed to them. Trying to register the site perhaps is not designed to actually succeed at this, but note it right away that it's spilled back to the attacker the underlying SQL script, so the symbols that are involved and so forth. In this case, the table name customers_info, obviously a very important table. So now I have that table name. If I wanted to run a drop table script, if I tried to inject a SQL script to drop table customers info, then I could do a great deal of damage to the site quite easily. So they should be suppressing the messaging going out to the general public from the site. A little bit lighter, password autocomplete. Many sites offer you the convenient opportunity to save your password so that you can come back to the site again. May not be such a good practice all the time, especially for a commercial site involving money or a site that maybe people are logging into from public computers or not. So not mandatory, not a big recommendation, but probably they could script it to not offer autocomplete for passwords. That's what we're doing here. More serious, so clickjacking. you'll see this if top.location not equal location. That's something we learned about in class about frame busting. So trying to prevent framing here. In IE, we've used the location equals clobbered to defeat that that navigation. In some of the quiz work, some of us used a 204 page, and then it constantly goes to the 204 page in a loop, and then that kills navigation as well as another way to defeat the navigation and to prevent frame busting. X-frame options is another way. It doesn't necessarily work in all browsers, but what they've done here can be easily defeated, and they should try these other techniques that we're talking about here. And in fact, actually, the X-frame options, there was a survey done, I think it was in our reading or materials, that had not been used very widely. So some other things that were pretty obvious, so the login page itself is not even using SSL. It's not even using HTTPS. So username, password, other sensitive information on a number of pages in the site, they're not even using a certificate to get a secure channel. So a passive network attacker eavesdropping on the network could probably monitor that traffic and capture this information, these passwords, an obvious vulnerability. Lack of secret validation. So they're using cookies for authentication. A better practice would be to add to that a secondary token, such as in a forum post. You could actually be requiring that token to go across. They actually had two pieces of information, so we would recommend adding secret validation tokens underneath. The third bullet, self-signed certificate. That's perfectly valid. You can do that. You can get a secure channel. The only comment on that is from a trust indicator standpoint, the user is going to see a warning that it's a self-signed certificate. Probably a better practice from a user standpoint or user interaction standpoint and trust indicator standpoint to go ahead and get a validated certificate from a certificate authority that's not going to cause that warning message to go up to and alarm the user. And finally, more serious is mixed content. So in some of the pages that are under HTTPS, they do contain references to HTTP content, and that obviously opens up the vulnerability of basically can defeat the HTTPS secure connection and offer inroads for the hacker. So that's our presentation. We appreciate you listening to us, and we very much enjoyed the class. Thank you very much. Bye now.